Welcome to lecture 3A of module 2 in database management system. Today we are going to see a new concept called relational algebra. We are all familiar with the structured query language. The structured query language is actually used to retrieve information from the database. So it is actually a query language. Similar to a structured query language, this relational algebra is another type of query language which is also used to retrieve informations from the database. It is having some set of operations. Using that operation, we can perform various tasks in the database. Okay. So this relational algebra, the difference between the SQL and the relational algebra is that relational algebra is a procedural query language. Okay, we'll be writing certain procedures for performing certain operations in the database. Okay, so that is called a relational algebra. So this relational algebra, we are going to see certain major operations. These operations can be used for performing various tasks in the database system. Okay, let us see in detail. The relational algebra is a procedural query language which takes the relation as input and generate the relation as output. Okay, so it is a procedural language. It takes one relation. Okay, it takes one relation as input and it generates another relation as the output. Okay, it will take one relation as an input and process it and give another relation as the output. The basic set of operations for the relational model is the relational algebra. Okay, so this basic set of operations for relational model, the relational algebra is also it is another definition for the relational algebra. It is a basic set of operations for relational model. Okay, for relational model means what is the relational model? Database represented in the form of tables, that is called a relational model. അപ്പോൾ ആ റിലേഷണൽ മോഡൽ ഓപ്പറേറ്റ് ചെയ്യാൻ ഉപയോഗിക്കുന്ന വേറൊരു കോൺസെപ്റ്റാണ് റിലേഷണൽ ഓൾജിബ്ര എന്ന് പറയുന്നത്. Okay, it is having a basic set of operations for relational model. These operations enable a user to specify basic retrieval request as a relational algebra expressions. Okay, അതായത് നമുക്ക് ഈ ഓപ്പറേഷൻസ് ബേസിക് സെറ്റ് ഓഫ് ഓപ്പറേഷൻസ് എന്ന് പറഞ്ഞാൽ എന്താണ്? ഇറ്റ് ഈസ് ഹാവിങ് സം റിട്രീവൽ റിക്വസ്റ്റ്. ഓക്കെ, റിട്രീവൽ, വാട്ട് ഈസ് മീൻ ബൈ റിട്രീവൽ? റിട്രീവൽ മീൻ ആക്സസിങ് ഡാറ്റ ഫ്രം ദ ഡാറ്റാബേസ്. ഓക്കെ, അപ്പോൾ ബേസിക് റിട്രീവൽ റിക്വസ്റ്റ് ആസ് ദ റിലേഷണൽ ഓൾജിബ്ര എക്സ്പ്രഷൻസ്. അപ്പോൾ ഈ റിട്രീവൽ റിക്വസ്റ്റ് നമ്മൾ എങ്ങനെയാണ് കൊടുക്കുന്നത്? ആസ് എ റിലേഷണൽ ഓൾജിബ്ര എക്സ്പ്രഷൻസ്. കുറേ എക്സ്പ്രഷൻസ് ഉപയോഗിച്ചിട്ടാണ് നമ്മൾ ആ റിട്രീവൽ റിക്വസ്റ്റ് നമ്മൾ പ്രിപ്പയർ ചെയ്യുന്നത്. Okay, relational algebra is composed of various operations. Relational algebra is having different types of operations. So let us see each operations in detail. Okay, so the first operation is the select operation. Okay, select operation. The select operation is actually used to choose particular rows or tuples from a relation. നമുക്ക് ഒരു ടേബിളിൽ നിന്ന് അല്ലെങ്കിൽ ഒരു റിലേഷനിൽ നിന്ന് നമുക്ക് ടപ്പിൾസ് അല്ലെങ്കിൽ റെക്കോർഡ്സ് മാത്രം എടുക്കണമെന്നുണ്ടെങ്കിൽ വിൽ ബി യൂസിങ് ദിസ് ഓപ്പറേഷൻ, ദിസ് ഓപ്പറേറ്റർ കോൾഡ് സിഗ്മ ഓർ ദ സെലക്ട് ഓപ്പറേഷൻ. Okay, so the select operation is used to choose a tuple or rows. Tuple means rows from a relation that satisfies a particular selection condition. Okay, so this tuple എങ്ങനെ സെലക്ട് ചെയ്യുന്നത്? The tuple is selected based on a selection condition. Okay, if we satisfy those selection conditions, that particular tuples will be selected. Okay, so in the select operation is denoted by this one, sigma select condition. At the end we will give the relation name or the table name. So R represent relation name. Okay, where the symbol sigma is used to denote the select operation. Sigma is used for select operation. And the selection condition is a Boolean expression condition. Okay, it can be a Boolean expression. Okay, it can be a Boolean expression or any form of selection condition can be used here. Okay, that we will show in the example. Now, R represents the relation name. Okay, let us see an example for this. So this is a table, this is a relation called employee. Okay, we are going to select the employee tuple. Okay, select the employee whose department number is 4 or whose salary is greater than 30,000. Okay, that is we are going to select employees details with the department number 4. Okay, department number 4 ഉള്ള employee details നമ്മൾ select ചെയ്യണം. Also we are going to select employee details having salary greater than 30,000. Okay, so we'll write the query like this: sigma, the first one is what? Sigma D number equal to 4. Okay, D number equal to 4 of employee. Okay, D number equal to 4 of employee. What do you mean by that? We are selecting, this is the selection operator and this is the selection condition. Okay, department number 4 ഉള്ള റോസ് അല്ലെങ്കിൽ ടപ്പിൾസ് സെലക്ട് ചെയ്യുക. ഡിപ്പാർട്ട്മെൻറ്റ് നമ്പർ 4. ഓക്കെ, ഫ്രം വിച്ച് ടേബിൾ? ഫ്രം ദ ടേബിൾ എംപ്ലോയി. Okay, from which relation? Relation is employee. Clear? Next what we are going to select the salary, employee whose salary is greater than 30,000. Okay, so sigma salary greater than 30,000. Okay, ഇതിൽ 30,000 മുകളിലുള്ള ആൾക്കാരുടെ ആ റോ മാത്രം സെലക്ട് ചെയ്യും. Okay, so the salary greater than 30,000 of employee. Okay, salary greater than 30,000 of employee. Clear? ഇതാണ് സംഭവം. Okay, so after executing this, only the row specifying this condition will be selected. അതായത് ഡിപ്പാർട്ട്മെൻറ്റ് നമ്പർ 4 എത്ര റോ ഉണ്ട്? 1, 2, 3. So these 3 rows will be selected. Okay, similarly for next query, salary greater than 30,000. How many rows are there having salary greater than 30,000? This is 40,000. Yes, this will be selected. Then this will be selected. 43,000 will be selected. Then this will be selected. 38,000 will be selected. Then 55,000 will be selected. So 4 rows will be selected. Okay, so this is the way of select operation. Okay, suppose if we want, we can give multiple conditions in a single selection operation. Okay, so these two can be combined. Okay, for example, to select the tuples of all employees who either work in the department number 4 and make over $25,000 per year, or work in the department number 5 and make over 30,000. Okay, so we can specify these 3 conditions using these 2 conditions in a single select operation. അപ്പോൾ ഇവിടുത്തെ കണ്ടീഷൻ എന്താണ്? We need to select the tuples or select the employee details who work in the department number 4 and make over 25,000. Okay, that is one condition. So select D number equal to 4 and salary greater than 25,000. Okay, or next is what? Or work in the department number 5 and salary greater than 30,000. Okay, salary greater than 30,000. Okay, അപ്പോൾ ഈ എല്ലാ കണ്ടീഷൻസും നമുക്ക് ഒറ്റ സെലക്ട് ഓപ്പറേഷൻസ് നമുക്ക് കൊടുക്കാൻ പറ്റും. Okay, first set of condition was this one. The salary department number 4 and salary must be greater than 25,000, or department number 5 and salary greater than 30,000. Okay, okay, so these conditions exist for which relation? That is given here. Okay, so you remember that this selection condition must be given in subscript. ഇത് നമ്മൾ സബ്സ്ക്രിപ്റ്റ് ആയിട്ടാണ് എഴുതേണ്ടത്. ഫസ്റ്റ് യു റൈറ്റ് എ സെലക്ഷൻ ഓപ്പറേഷൻ സിഗ്മ, then the selection condition must be given in the subscript. Okay, then the relation must be written in normal form. Okay, normally. Clear? So this is the concept. So while executing this query on this table, we will be getting this result. Okay, ഇപ്പോൾ ഡിപ്പാർട്ട്മെൻറ്റ് നമ്പർ 4ഉം 5 ഉള്ള ആൾക്കാരുടെ ഡീറ്റെയിൽസും സാലറി 25,000ഉം 30,000 മുകളിലുള്ള ആൾക്കാരുടെ ഡീറ്റെയിൽസും ഇതിനകത്ത് ഡിസ്പ്ലേ ആവും. Okay, so select operation, remember that select operation is used for selecting a particular tuple or row from a relation. Okay, next project operation. So project operation എന്ന് പറഞ്ഞു കഴിയുമ്പോഴത്തേക്കും നമ്മളെന്താണ് ഒരു ആട്രിബ്യൂട്ട് അല്ലെങ്കിൽ കോളം സെലക്ട് ചെയ്യാൻ വേണ്ടിയിട്ടാണ് പ്രൊജക്റ്റ് ഓപ്പറേഷൻ ഉപയോഗിക്കുന്നത്. Okay, so project operation is select certain column from the table and discards the other column. Okay, so project operation is used to select a particular column or attribute from a relation. Okay, and it will discard the rest of the column. The general form is like this: pi. Okay, the project operation is pi. Clear? Sigma, the select operation is sigma, project operation is pi. So pi attribute list of R. So pi is a symbol used to represent the project operation. Attribute list is the list of the attribute from the attribute of the relation R. Okay, ഇതാണ് അതിൻ്റെ ഫോം എന്ന് പറയുന്നത്. Clear? So project operation is for selecting projecting the attribute list or column. Select operation is for selecting the tuples. Okay. Now, for example, in the given table, the list each employee's first name and last name. Okay, each employee's list first name and last name and salary we can and salary. Okay, first name, last name and salary. ഇത് മൂന്നും ഡിസ്പ്ലേ ആണ്. Okay, we want to select 3 attributes. What are they? First name, last name and salary of this one from this relation. Okay, so we can write like this: project pi first name. Okay, first name, f name, l name and salary. Salary is this one. Okay, salary of what? Which relation? Employee. Okay, so after executing this relational algebra expression, this will be your result. Okay, l name, f name, salary. Okay, another example. For example, to list each employee first name and last name and salary whose salary is greater than 30,000. Okay, so here we are going to combine what? The select and the project operation. Okay, so ഇവിടെ നമുക്ക് എന്താ വേണ്ടത്? Here we are going to list the employees first name and last name and also salary greater than 30,000. Okay, so first we do is we select the rows. First task is that we will select the rows having salary greater than 30,000. That is our first task. Okay, so we will select the select operator, then we will write salary greater than 30,000. Okay, actually this salary greater than 30,000 must be written in subscript. Okay, this was a mistake. Actually this must be written in subscript. So select salary greater than 30,000 of which relation? Employee. Okay, so after executing this, we will only the rows having salary greater than 30,000 will be displayed. Okay, from that we will select the column. Which column? We will select the column first name and last name. Okay, so this will be outside this one, outside the selection operation, we will write the project operation. Okay, ഇപ്പോൾ project operation എപ്പോഴും എഴുതുന്നത് അങ്ങനെയാണ്. സെലക്ഷൻ ഓപ്പറേഷന് പുറത്താണ് പ്രൊജക്റ്റ് ഓപ്പറേഷൻ എഴുതുന്നത്. Okay, so pi of first name comma last name will be written outside. Clear? Next question. To retrieve the first name and last name and salary of the employee who work in the department number 5. Okay, so department number 5, this is the selection condition. So what we have to do? For department number 5 ഉള്ള എംപ്ലോയീസിൻ്റെ ടപ്പിൾസ് സെലക്ട് ചെയ്യും. ഓക്കെ, ടപ്പിൾസ് സെലക്ട് ചെയ്തിട്ട് അപ്പോൾ അതിന്ന് നമ്മൾ എന്ത് ചെയ്യുന്നു? നമ്മൾ ഫസ്റ്റ് നെയിം, ലാസ്റ്റ് നെയിം ആൻഡ് സാലറി ഉള്ള ആട്രിബ്യൂട്ട്സ് എടുക്കും. Okay, so first we will select the tuples having department number 5. Okay, so sigma department number 5 employee. Okay, from that we will select what? So after executing this one, the rows having department number 5 will be selected. Okay, from that we have to display the what? The first name, last name and salary of the employee. Okay, so pi first name, last name and salary. Okay, so this is the way. Clear? So sigma department number equal to 5 of employee. Okay, department number 5 of employee, sorry, department number 5 of employee means the department number, the rows having department number 5 will be selected. From that we will select the attributes first name, last name and salary. Okay, this is how we can combine a selection as well as projection operation. Okay, so hope all are clear with the selection and projection operation. Next operation is union, intersection and minus operation. Suppose we are having two relations R and S. So R is having the attributes A1, A2 etc. up to AN, and S is having attributes B1, B2 etc. up to Bn. Okay, so union operation, union means that union means R union S, which means that which is having all the attributes of R as well as all the attributes of S. Okay, that is called the union operation. Look at here. So this is student and this is instructor. Okay, so student, instructor. So the condition is that, so these two, in order to combine or in order to perform union operation, the attribute must be same of the or attribute of these must be of the same type. Otherwise union cannot be performed. ഇപ്പോൾ ഇവിടെ കണ്ടോ, ഇവിടെ സ്റ്റുഡൻറ്റ് ടേബിളിൽ the attribute is first name and last name. Instructor is also having the attributes first name and last name. Only such two relations having same attributes can be combined. Okay, so student union instructor എന്ന് പറഞ്ഞാൽ എന്താണ്? It is having all the attributes of student and all the attributes of instructor. Okay, so this is student union instructor. Okay, so we will take all the attributes of student and all the attributes of instructor. Okay, that is called union. So result is this operation denoted by R union S is a relation that includes all the tuples that are either in R or in S or in both R and S. Okay, so it includes all the tuples that are available in R and S. Okay, but duplicate tuples are eliminated. Here the duplicate tuples will be eliminated. There may be duplicate tuples that will be eliminated. Okay, because here look at here, Susan Yao. Okay, here also it is Susan is available here. So such tuples will be eliminated in the combined relation, union relation. Okay. So what about next concept, intersection? Intersection, what is intersection? Only the tuples having common to both will be displayed. Okay, so here Susan and Susan Yao and Ramesh Shah. Okay, Ramesh Shah, these are common. Only those tuples will be displayed. That is student intersection instructor. Okay, so the result of this operation denoted by R intersection S is a relation that includes all the tuples that are in both R and S. R ലും S ലും കോമൺ ആയിട്ടുള്ളത് മാത്രം എടുക്കും. Okay, next is set difference. This is very important. Okay, set difference എന്ന് പറഞ്ഞാൽ എന്താണ്? The result of this operation denoted by R minus S. It is represented by R minus S is a relation that includes all the tuples that are in R but not in S. Okay, ആറിലുള്ള എല്ലാ ട്യൂപ്പിൾസും എടുക്കും, പക്ഷേ എസ്സിലുള്ളത് എടുക്കത്തില്ല. Okay, it takes all the tuples in R but not in S. Okay, look here, student instructor, student minus instructor. Okay, so here what we take, it will take all the tuples of student excluding the common tuples. Okay, the common ആയിട്ടുള്ള ഏതാണ്? Susan Yao, Ramesh Shah. Okay, that will be eliminated. Common ആയിട്ടുള്ളതല്ല eliminate ചെയ്യും, but except that it takes all the tuples from the student relation. Okay, അതാണ് student minus instructor. What about instructor minus student? It will take all the tuples of instructor, okay, except the common one between student and instructor. Except that it will take all the tuples in the instructor. Okay, അപ്പോൾ ഇവിടെ നമുക്ക് ആ സൂസനും രമേശും ആ രണ്ട് ടപ്പിൾസ് എലിമിനേറ്റ് ആയി. ഓക്കെ, ബട്ട് എക്സെപ്റ്റ് ദാറ്റ് all the tuples from the instructor is being selected. Okay, so that is the rule of what set difference. Okay, so R minus S means that it will take all the tuples in R but not in S. Okay, it will take all the tuples in R but not in S. That means that it will take student minus instructor means it will take all the values, all the tuples from student excluding the common one between student and instructor. Here also instructor minus student means it will take all the tuples from instructor except the common one between the instructor and the student. Okay, so this is the set difference operator. Okay, next is Cartesian product, which is very important concept, Cartesian product. So Cartesian product is an operation which is also called cross product or cross join, which is denoted by cross. Okay, it is denoted by a cross. So R cross S or R cross product S, the Cartesian product operation defines a relation that is the concatenation of every tuple of a relation R with every tuple of relation S. So R cross S means here it is a relation R. The every tuple of relation R is concatenated with every tuple of relation S. That is called R cross S. Okay, that is called cross product. Okay, so cross product means that the cross product R cross S means that every every tuple in R is concatenated with every tuple in S. Okay, let us see an example. Here student, instructor. Okay, here student is having 3 rows, 1, 2, 3, or 3 tuples. Instructor is having 2 tuples. Okay, so what we do is here student cross instructor, or student cross product instructor means all the rows in the student is concatenated with each and every rows in instructor. For example, this one Bina, it is concatenated with the instructor, the first row in the instructor as well as the second row in the instructor. Okay, so the resultant table will be like this. Okay, so this one Bina, so first row will be like this: one Bina, one Shamna Science. Okay, one Bina, one Shamna Science. Next is one Bina, two Anjali Max. One Bina, two Anjali Max. Okay, so this is over. Now next we will take the next tuple, 2 Ramu. That is also concatenated with the each and every row or tuple in the instructor relation. Okay, so 2 Ramu, 1 Shamna Science. 2 Ramu, 1 Shamna Science. Clear? Then 2 Ramu, 2 Anjali Max. 2 Ramu, 2 Anjali Max. Okay, next 3 Shilpa. This row is concatenated with each and every row in the next relation or instructor relation. So 3 Shilpa, 1 Shamna Science. 3 Shilpa, 1 Shamna Science. 3 Shilpa, 2 Anjali Max. 3 Shilpa, 2 Anjali Max. Okay, so this main drawback of this cross product is means that redundant values are here or occurring. Look here, this 1 Bina has occurred 2 times, 2 Ramu has occurred 2 times, 3 Shilpa has occurred 2 times. Okay, here also this Shamna Science, this also occurred 3 times, Anjali Max occurred 3 times. Okay, so redundant values will be occurring in the cross product. Okay, this is a main drawback of a cross product. Okay, so in order to reduce this drawback, we will be going into another concept called a join operation. Okay, that is what we are going to see in the next slide. Okay, so cross product, hope you have understood. Cross product എന്ന് പറഞ്ഞാൽ ഒന്നുമില്ല, ഓരോ റോയിലുള്ള വാല്യൂസ് തൊട്ടടുത്തുള്ള റിലേഷനുള്ള എല്ലാ റോ ആയിട്ട് കൺകാറ്റിനേറ്റ് ചെയ്യും. Okay, so if the student relation is having 3 rows, okay, and instructor is having 2 rows. Okay, so this student cross instructor will be having 3 into 2, 6 rows. 6 alle, 1, 2, 3, 4, 5, 6. Okay, 3 into 2, 6 rows will be here. Okay, that itself the rows will be redundant. Okay, so in order to remove this redundancy, we are going to another concept called join operation. Okay, we will combine these two tables using a join operation. Okay, so join operation denoted by, in relational algebra, this join operation is denoted by this symbol. This symbol is called join operation. It is used to combine related tuples from 2 relations into a single longer tuples. Okay, അപ്പോൾ റിലേറ്റഡ് ആയിട്ടുള്ള ടപ്പിൾസ് മാത്രം നമ്മൾ ജോയിൻ ചെയ്യും. ഓക്കെ, സോ സച്ച് ദാറ്റ് ഇറ്റ് വിൽ ബിക്കം എ സിംഗിൾ ലോങ്ങർ ടപ്പിൾ. ഓക്കെ, സിംഗിൾ ഒരു ബിഗ് റിലേഷനായിട്ട് മാറും. ബട്ട് ഓൺലി ദ റിലേറ്റഡ് ടപ്പിൾസ് വിൽ ബി ജോയിൻഡ് ഹിയർ. ഓക്കെ, ഓൺലി ദ റിലേറ്റഡ് ടപ്പിൾസ് വിൽ ബി ജോയിൻഡ് ഹിയർ. ഓക്കെ, എ ജോയിൻ കമ്പൈൻസ് 2 ടപ്പിൾസ് ഫ്രം 2 റിലേഷൻ ഓൺലി ഇഫ് ദ ജോയിൻ കണ്ടീഷൻ ഈസ് സാറ്റിസ്ഫൈഡ്. ഇപ്പോൾ ജോയിൻ കമ്പൈൻ എപ്പോഴാണ് കമ്പൈൻ ചെയ്യുന്നത്? ജോയിൻ ക്യാൻ ബി, ദ ജോയിൻ combines 2 tuples. The 2 tuples can be combined using join operation only if the join condition is satisfied. We will give a join condition. That condition must be satisfied. Only after that this join can be performed. Okay, example, retrieve the name of the manager of each department. Okay, we will see the example in the coming stage. So the join operation is being classified into three. Okay, first one is equi-join and natural join, then left outer join and right outer join. Okay, these are the three join operations. Okay, equi-join or natural join, left outer join and right outer join. Okay, let us explain this concept using an example. Okay, so natural join, first one is natural join. Natural join can only be performed if there is a common attribute between the relation. But natural join എപ്പോൾ ഓപ്പറേറ്റ് ചെയ്യാൻ പറ്റും? If the two relation is having a common attribute having the same attribute name. അങ്ങനെയാണെങ്കിൽ മാത്രം we can have natural join. Okay, the name and type of the common attribute must be same. നമ്മൾ ഏത് ആട്രിബ്യൂട്ട് വഴിയാണ് നമ്മൾ ജോയിൻ ചെയ്യുന്നത്, that attributes name as well as the type must be same. Okay, look at here, customer and order. Here we are having two tables, two relations, customer and order. So we are actually combining these two relations using join, customer order, customer join order. When we give this natural join operation, these two table will look for a common attribute, which is common here. CID is common here. Customer ID is common here, also customer ID is there. So these two are common. Okay, so the customer IDs that are the tuples having matching customer IDs will be displayed. Okay, for example 101, yes, 101, they are having a matching here. So this row and this row will be combined. Okay, so 101 Ajay 20 pizza 550. Okay, so that will be combined like this. One more thing you have to remember, that this CID, customer ID, will not be repeated in the joined column, joined relation. So this is a joined relation. This joined relation രണ്ട് കസ്റ്റമർ ഐ ഡി ഇല്ല. ഇത് നമ്മൾ ജോയിൻ ചെയ്യുമ്പോഴത്തേക്ക് ഒറ്റ കസ്റ്റമർ ഐ ഡി എടുക്കത്തുള്ളൂ. only a single customer ID will be considered. Okay, so 101 101, this will be joined. Now 102, is there any matching customer ID here? 102, no, it does not have any value, so that will be eliminated. Next 103, 103 does have a matching? Yes, 103 103. So 103 Sita 21 Noodle 300, that will be combined. Okay, similarly 104, is there have any matching? No, does not have any matching, that will be discarded. So only these two tuples will be joined. Okay, this is called natural join. Okay, so hope all are clear with the natural join. So natural join can be performed only if we have a common attribute having common name and the type. Okay, next is equi-join. Equi-join is also same as the natural join. Only thing that the common, we don't have the attribute, common attribute does not have the same name, but they will be having the same type, but the name will be different. Look at here, here customer and order. Here the common attribute actually is CID and OID. They are having the same type, but the attribute name is different. Okay, in that case what we do is we will use a equi-join concept. So equi-join means we will specify the equality condition, which attribute to be combined, that will be specified here. That is the only difference. Rest the operation is same, similar. Operation is same as the natural join. Okay, the most common use of join involves the join condition with the equality comparisons only. Okay, we have to specify the equality condition. Equality means which attribute to be combined, that will be specifying. In natural join it is not like. In natural join it will automatically find out which has to be combined by looking at the common attribute. Okay, here it is not like that. We have to specify which to be combined. Okay, such a join where only the comparison operator used is equal to. So here the equal to, only the equal operator is used. Okay, so such a join is called equi-join. Look here, here we have customer ID. Okay, so here we are going to combine this customer CID and the so look here, we are having CID, C name and age. Here we have order ID, order name. Okay, see here, here the order ID and the CID is having almost the same value, but the attribute name is given differently. Here it is given CID and here it is given OID. Okay, so we need to combine these two attributes. Okay, so we are going to combine these two combine the tuples using these two attributes. Okay, so customer join order. Okay, so which one we are going to combine? The customer dot customer ID. So customer dot customer ID and order dot order ID. Okay, we also must specify the relation name along with the attribute name. Okay, using dot operator. Okay, so customer customer ID order order ID. That is specify customer dot customer ID equal to order dot order ID. ഇത് രണ്ടുമായിട്ടാണ് ജോയിൻ ചെയ്യേണ്ടത് എന്ന് നമ്മൾ സ്പെസിഫൈ. ഓക്കെ, അപ്പോൾ ഇതെങ്ങനെയാണ് ചെയ്യുന്നത്? It will 101, it will check whether any 101 is there. Yeah, 101 pizza is there, so this row will be selected. 101 Ajay 20 pizza, 101 Ajay 20 pizza. Is there any more 101? Yes, 101 noodles is there, so 101 Ajay 20 noodles, 101 Ajay 20 noodles. Okay, what about 102? Is there any matching value? No, so it will not take. 103, is there any matching value? Yes. Okay, so 103 see the 21 burger, 103 see the 21 burger, that will be selected. Okay, so this is called equi-join. This is called equi-join. Okay, in our all examples we will be using this equi-join concept. Okay, we will be specifying the attribute that is to be combined. Okay, in our questions also, even if we are having the same attribute name, we will be specify this equi-join method. അതായത് നമുക്ക് ക്വസ്റ്റ്യൻസിൽ ചിലപ്പോൾ രണ്ടും ഒരേ ആട്രിബ്യൂട്ട് ആണെങ്കിൽ പോലും നമ്മൾ ഇത് സ്പെസിഫൈ ചെയ്യും. ഓക്കെ, equi-join നമ്മൾ സ്പെസിഫൈ ചെയ്യും. Okay, that is a common method that we are adopting. Okay, so it will be more clear when we see the examples. Okay, example, retrieve the name of the manager of each department. Okay, we need to get the manager's details. So this is the truth table. Okay, we have to retrieve the manager's name. So look here. Here we have the employee details. If employee details, see here, in the employee details we are having all the details of the employee, including their name, first name, last name, middle name, their employee number. This is the employee number. SSN is the employee number, birth date, address, sex, salary, supervisor SSN, D number. All these details are given. Okay, in the department table we need to from this we want to select which of the employees are manager. So look at the department table. Department table we are having the attributes like department name, department number, manager SSN. Look at here, manager SSN. So this means that this is the SSN number of managers. Okay, അപ്പോൾ ഈ റിസർച്ച് ഡിപ്പാർട്ട്മെൻറ്റ് കൺട്രോൾ ചെയ്യുന്ന ഈ മാനേജറാണ്, അഡ്മിനിസ്ട്രേഷൻ ഡിപ്പാർട്ട്മെൻറ്റ് കൺട്രോൾ ചെയ്യുന്ന ഈ മാനേജറാണ്, ഹെഡ് ക്വാർട്ടേഴ്സ് ഇത് കൺട്രോൾ ചെയ്യുന്ന ഈ മാനേജറാണ്. സോ വി ആർ ഹാവിങ് ദ മാനേജർ SSN. So this is the manager ID of the managers. Okay, so this has to be matched with the SSN. അങ്ങനെയാണെങ്കിൽ we can select the manager's name from here. അല്ലേ, ഇതും മാച്ചായി കഴിഞ്ഞു കഴിഞ്ഞാൽ നമുക്ക് വേണമെങ്കിൽ എന്ത് ചെയ്യാൻ പറ്റും, ഇതിന്ന് നമുക്ക് മാനേജറാണെന്ന് കണ്ടുപിടിക്കാൻ പറ്റും. അല്ലേ, 333445555 കണ്ടോ, അങ്ങനെ വാല്യൂ ഉണ്ടോ? യെസ്, ഹിയർ ദർ ഇസ് എ വാല്യൂ. സോ ദിസ് ഫ്രാങ്ക്ലിൻ ഈസ് എ മാനേജർ. ഓക്കെ, 98765432 9876, is there any value? Yes, 9876, yes, there is a value here, that is Jennifer. So Jennifer is also a manager. Okay, 88866555 88866555, so James, he is also a manager. ഓക്കെ, അപ്പോൾ ഇതെന്ന് നമുക്ക് മാനേജറിന് നമുക്ക് കണ്ടുപിടിക്കാൻ പറ്റും ഇങ്ങനെയാണെങ്കിൽ മാച്ചിങ് നോക്കിയിട്ട്. ഓക്കെ, അപ്പോൾ അതിന് നമ്മൾ എന്ത് ചെയ്യണം? വി ഹാവ് ടു ജോയിൻ ദീസ് ടു റിലേഷൻ. ഓക്കെ, സോ ഫസ്റ്റ് വി ഹാവ് ജോയിൻ ദ ഡിപ്പാർട്ട്മെൻറ്റ് ആസ് വെൽ ആസ് ദ എംപ്ലോയി റിലേഷൻ. ഡിപ്പാർട്ട്മെൻറ്റ് ആൻഡ് ദ എംപ്ലോയി റിലേഷൻ ജോയിൻ ചെയ്യുന്നു. ഓക്കെ, വാട്ട് ഈസ് ദ ഇക്വാലിറ്റി കണ്ടീഷൻ? മാനേജർ SSN ഈക്വൽ ടു SSN. ഓക്കെ, either we can write department dot manager SSN equal to employee dot SSN. ഓക്കെ, അങ്ങനെ എഴുതാത്തതിൻ്റെ കാര്യം എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ രണ്ടും വ്യത്യസ്തമായ പേരുകളായതുകൊണ്ടാണ്. ഇവിടെ MGR SSNും ഇവിടെ SS ആയതുകൊണ്ടാണ് നമ്മൾ ഇതിന് മുമ്പായിട്ട് എന്താണ് ടേബിളിൻ്റെ പേര് എഴുതാത്തത്. Okay, since the attributes, the common attribute is having different names, we are not specifying the table name. Same ആയിരുന്നെങ്കിൽ we would have written department.manager SSN equal to employee.ssn. Okay, അങ്ങനെ എഴുതിയാലും പ്രശ്നമൊന്നുമില്ല. Okay, so after this one we will combine these two relations and only the matching rows will be selected. Only the matching rows will be selected. So these two tables can be combined into a single table having this matching rows. Okay, from that matching rows we will project what we want to retrieve the name of the manager. We will project the manager name, first name, last name and middle name. Okay, first name, last name and middle name. Okay, so retrieve the name of the manager of each department. Okay, also we want to display the department name also we want to display. Okay, so department name, so we will project the department name, last name and first name. Okay, so before that, look at here, this joined relation is actually stored in a separate. So from this joined relation, so this joined relation is actually stored in an intermediate result called department manager, or whatever the name, നമുക്ക് എന്ത് പേര് വേണം നമുക്ക് ഇവിടെ കൊടുക്കാം. Okay, whatever name we wish to use, we can use it. Okay, here we have given department manager. So this joined relation is stored in a intermediate relation called department manager. Okay, so this department manager will be having all the details of employee and the department having this equality relation. അതായത് മാനേജർ SSN ഇക്വാലിറ്റി ചെയ്ത എല്ലാ ടപ്പിൾസും ഇതിനകത്തുണ്ടാവും. From that, what we will project the department name, last name and the first name. Okay, we are projecting the department name, last name and first name from this intermediate result. Okay, intermediate result. So this will be stored in the final resultant relation. Okay, it is better to write this relational algebra statements like this. ഇതുപോലത്തെ ഇൻ്റർമീഡിയറ്റ് റിസൾട്ടുള്ള രീതിയിൽ എഴുതുന്നതാണ് ഏറ്റവും നല്ലത്. ദാറ്റ് ഈസ് എ ബെറ്റർ വേ. ഓക്കെ, we will not commit any mistake. Okay, we can also combine these two. Okay, ഇതിന് നമുക്ക് ഈ രണ്ടെണ്ണത്തിനെയും we can combine into a single relational algebra expression like this. Okay, first of all we can join these two. Okay, this joined relation, on this joined relation we will applying the project operation. Okay, on this joined operation, joined one we will applying this project operation. Okay, so pi d name, l name, f name of on this one. Okay, so this is the another concept. Clear? So this is how we can this is how we write a relational algebra using join operation. Okay, there is a small mistake here. I have told that this two intermediate result can be combined into a single. I have already told that. Okay, so first we will apply this join of the department and the employee table using this MGR SSN and SSN. Okay, on these joined relation we will be applying the project operation. So we don't need this one, department manager എന്നുള്ളത് we don't require. Okay, so we can apply the project operation on this joined relation. That is the correct method. Okay, so this is the natural join and equi-join. Next concept is left outer join. Okay, so this join returns all the rows of the table on the left side of the join and matching rows on the table on the right side of join. Okay, അതായത് ലെഫ്റ്റ് ജോയിൻ എന്ന് പറയുമ്പോഴത്തേക്ക് ലെഫ്റ്റ് ജോയിൻ ഈസ് ആക്ച്വലി റെപ്രസെൻറ്റഡ് ലൈക്ക് ദിസ്. ഓക്കെ, ആ ജോയിൻ ഓപ്പറേഷൻ്റെ അവിടെ ലെഫ്റ്റ് സൈഡിൽ വിൽ ബി പുട്ടിങ് ടു horizontal lines, that is left join. Okay, so left join means that we will take all the values in the left table and also the matching values in the right table. This is called a left join. Consider this table. Okay, so A and B. Okay, so we will take all the values. So here the matching that these tables are combined using the attribute called name. അല്ലേ, നെയിം ആണ് കോമൺ ആയിട്ടുള്ളത്. അപ്പോൾ നെയിം വെച്ചിട്ടാണ് നമ്മൾ എന്ത് ചെയ്യുന്നത്, വിൽ ബി കമ്പൈനിങ് ദീസ് ടു ടേബിൾസ്. സോ ഹിയർ this j, first we will take all the values from the left. We will consider all the values from the left table. So 10j, 20 Veer, 30 John, all these values will be written here. Okay, then also we will take the matching values in the right table. Okay, so j, is there any matching value for j? No. Okay, so j does not have any matching value for this, so that field will be kept as null. അത് നമ്മൾ നള്ളായിട്ട് എഴുതും, കാരണം അതിന് അവിടെ മാച്ചിങ് റൈറ്റ് ടേബിളിൽ അതിന് മാച്ചിങ് വാല്യൂ ഇല്ല, അതുകൊണ്ട് നമ്മൾ നള്ളായിട്ട് എഴുതും. ഓക്കെ, വാട്ട് അബൌട്ട് വീർ? വീർ ഈസ് ഹാവിങ് എ മാച്ചിങ് വാല്യൂ ഫോർ ദ മാർക്ക്, സോ വിൽ ബി ഫിൽ ഇറ്റ് വിത്ത് 18. ജോൺ ഈസ് ഹാവിങ് എ മാച്ചിങ് വാല്യൂ ഫോർ ദാറ്റ്, വിൽ റൈറ്റ് ദ മാച്ചിങ് വാല്യൂ 14. So here we are not including Sam here, because why? Because we are only taking all the values from the left table and only the matching values in the right table. Okay, so we are not including Sam here. Clear? So this is called left join. Okay, left join. Clear? So left join means we will take all the values in the left table and the common values in the right table. Okay, if you don't have any matching value, that field will be written as null. Okay, next is right join. So right join is similar to left join. Here the join returns all the rows table on the right side of the join and matching on the left side of the join. Okay, that is called right join. അപ്പോൾ ഇവിടെ എങ്ങനെയാണ് ചെയ്യുന്നത്? You will take all the values in the right table and only the common values in the left table. Okay, so here this is represented like this: A right join B. അപ്പോൾ നമ്മുടെ റൈറ്റ് സൈഡിൽ വിൽ ബി ഗിവിങ് എ horizontal line. Okay, so here what we do, we will take all the, this is A right join B. Okay, we will take all the values in the right table. Okay, so name, marks. Okay, so Rohan 20, Veer 18, John 14, Sam 18. So all these values we have taken. Okay, then we also take the matching values in the left table. Okay, so Rohan, does Rohan have a matching value here? No, Rohan does not have, so that ID field will be kept null. So Veer, does he have a matching? Yes, so ID is 20. John, yes, ID is 30. Okay, Sam, does Sam have any matching value? So no, so it will be kept null. Okay, so this is called right join. Okay, right join will take all the values in the right table and the common values in the left table. Okay, if there is does not have any matching, then that will be kept as null. Okay, the rows for which there is no matching row on the left side, the results will be the result set will contain null. Okay, അപ്പോൾ അങ്ങനെ മാച്ചിങ് ഇല്ലാത്ത ഫീൽഡുകളിൽ വിൽ ബി ഗിവിങ് null. Clear? The right join is also called right outer join. This right join is also called right outer join. Left join അങ്ങനെ പറഞ്ഞിട്ടുണ്ട്. Left join is also called left outer join. Okay. Next is full join. So full outer join or full join creates the result set by combining the results of both the left join and right join. Okay, so this is the combination of left join and right join. That means that we will take all the values from the left table and all the values in the right table. Okay, so the result will contain all the rows from both the tables. രണ്ട് ടേബിളിലുള്ള എല്ലാ വാല്യൂസും നമ്മൾ എടുക്കും. ഓക്കെ, ഇല്ലാത്ത ഫീൽഡുകളിൽ നമുക്ക് മാച്ചിങ് ഇല്ലാത്ത ഫീൽഡുകളിൽ വിൽ ബി പ്രൊവൈഡിങ് നൾ വാല്യൂസ്. ദ റോ ഫോർ വിച്ച് ദർ ഇസ് നോ മാച്ചിങ്, ദ റിസൾട്ട് സെറ്റ് വിൽ കണ്ടെയ്ൻ നൾ വാല്യൂസ്. Okay, look at here. So ID, name, mark. So here the matching attribute is name. Okay, so you will take all the values. So 10J, you will take 10J, 20 Veer, 30 John, all the values you have taken. Okay, and also we will also take about Rohan. Rohan also take, Sam will also be taken. Okay, so J does not have any matching value for mark, so this mark will be field will be kept as null. Okay, this Rohan does not have any matching value, so this for Rohan the ID will be null. For Rohan the ID will be null. Sam also does not have any matching value for the left table, so this for Sam also, Sam the ID will be null. Okay, so this full join means you will take all the values from both the tables and if there is no matching for a particular field, that field will be set as null value. Okay, so this is the concept of join operation. Okay, so we have studied three concepts, three join concepts, that is what, natural join and equi-join, left outer join and right outer join. Okay, so in problems and all we will be mostly encountering this equi-join concepts. Okay, equi-join concepts വെച്ചാണ് നമ്മൾ problems എല്ലാം ചെയ്യാൻ പോകുന്നത്. Okay, so in the next session we will be seeing the problems, university problems based on this relational algebra. Okay, thank you.